Welcome students to another lesson with Mr. Kinnett over our nice flip classroom. So as you can see, today's lesson will be about unit rates. And our goal is to be how do we create a unit rate and use them when comparing things. Now if these vocab words are not making sense like unit rate, please try to copy down the chapter 5 vocab ahead of time because then you can reference that as you are confused throughout this lesson. I'm going to ask that you pause here to copy the two screens down. Welcome back. Okay, so how do we create a unit rate? We can't use them to compare things if we don't know how to make them first. So here's an example. We're going to read the sentence. Okay, well, we're reading the sentence, and like I've always taught you, we want to circle things we care about. So first off, this is the direction being asked for. It's asking us for us to compare things as a unit rate. And a unit rate is any type of ratio that has a denominator equal to 1. So the first thing it talks about is 400 miles on 14 gallons of gasoline. So we're going to create a ratio of 400 miles to 14 gallons. That's GAL. Sorry, my board ran out right there. Okay, so now we should probably write that as a fraction so it looks more normal. And the units in this whole chapter are really going to matter. So we want to leave them there. And miles won't cancel with gallons at all. But what we're actually going to be discovering in this problem is the miles per 1 gallon of gasoline. So what we need to do is we need to get this to a unit rate. So the denominator has to be created into the number 1. And to do that, what number could we divide 14 by to make 1? Yes, you're right. We have to divide it by 14. And then, just like in every other ratio or fraction skill we've learned, we have to be fair and do that to the top as well. So the bottom math is quite simple. 14 divided by 14 is 1 gallon. And now we have to do the numerator here. And this is actually going to be long division. So we have 400 divided by 14. 14 goes into 400 how many times? Oh man, okay, we'll do this one number at a time here. How many times does 14 go into 40? Let's do some multiple guesses here. Remember, when we do long division, it's okay to do some guess and check. So that's too big, so it's definitely a 2. And that gets us 28 that we subtract. 120. I'm going to have to check another one. 42 times, let's try 5. 210 was way too large. Well, that's because I multiplied by 42. Oh man, someone's going to pick on me tomorrow. Let's actually do 14 instead. Still too small. Remember, don't erase your hypotheses with the guess and checks here, because you may be able to use a guess that's wrong now, later on, when it could be correct. Okay, so we're getting close. Pretty sure it's going to be 14 times 8 now. Yes, that does fit. Okay, so again, we're just doing our guess and check with our long division here. And we just guessed that would be an 8. It turned out correct. We're going to have to add a 0 here because it has not terminated yet. That's why we keep our guesses, because now we know that's a 5 already without having to do any extra math. And that gets us 70. We're going to have to add another 0 here. It goes into 100 7 times. And this is not going to repeat for a while. So I'm going to edit our directions and say, we are allowed to stop at our 100th place. So what we've just learned is that 400 is divided by 14 is approximately, that's what this symbol means, 28.57 miles. So what we've learned here is that in this trip, every gallon of gas will get us approximately 28.57 miles. And we have created a unit rate. Okay, let's try another problem together here. See if that works. So we're converting $19.49 for 6 pounds into a unit rate. That's our goal here. Oh, and this does tell us to round to the nearest cent. Thank goodness. I probably should have added that direction to the previous problem. I'm going to have you pause here because I've realized I did not have you copy it down yet. Okay, welcome back. So $19 is set first for 6 pounds. Well, what number can we divide the bottom by to get it to become a number 1? Yeah, you're right. It's a number 6, and then we have to be fair and divide the top by the same number. So the bottom will be down to 1 pound, and 1949 divided by 6. You can see we're going to be doing a decent amount of long division here. And I'm doing my long division quick, so feel free to pause and take your time doing it yourself. And that's 4. And we need a thousandths place because we should round if it's necessary. And we're good. Okay, so $3.248. Oh, well, we need to round to cents, so this is going to kick our up number there. So it's $3.25 for every 1 pound. That's our unit rate. And again, why we're going to start doing this is unit rates help us compare things when marketing or companies are trying to hide actual costs for things. We're going to learn how this affects us in supermarkets all the time. So for question 4 here, I'm going to have you copy it down and then leave about a thumb's length below this problem so we have room to actually do it in class. And I'm going to actually click 2 pages ahead and ask you to pause and copy this down. Please remember to leave space below example 3. Awesome, welcome back. So again, we're going to do example 3 together in class. And really the focus of creating unit rates is so that we're able to compare 2 rates that look different. In this example, you can see they're going to ask us to create 2 unit rates so that we can compare them in the end. I'm going to do this problem with you in class as well. The question I want to leave you with is, how come I have to call our end answer in this box here a ratio rather than a fraction? Why, even though it looks like a fraction, do we have to call it a ratio? And my hint would be, go look up what the definition of a rational number has to be. Well, that's all today. I hope that wasn't too bad. Thanks for listening, and we'll finish those last 2 problems in class.